pH and pOH. What is pH? pH is just the power of hydrogen. So we want to estimate how much concentration of hydrogen we have in the solution. Okay, it's the same thing for, or similarly for the pOH, it's just the power of hydroxide. Now, in the previous video, we looked at Kw as being equal to 1 times 10 to the power of negative 14, okay, mole squared over liter squared. This here was our concentration, okay? In case you kind of confused, okay, about Kw, Kw is pretty much the ion product constant. Now this honestly is just a fancy word for saying the equilibrium constant of water, okay? We looked at in the previous video. Okay, link is in the description below if you want to have a look at that before this video. Okay, this here was the equilibrium constant of water, and we also put that this here, right, is equal to the product of OH minus multiplied by the hydronium. Okay, so you multiply these two as a product, it equals this, and technically Kw, the ion product constant of water, is equal to this product as well. Okay, we looked at a derivation of this in this previous in the previous video. Now, how are we going to break this down? Okay, this power of hydrogen. I want to emphasize on this one. Well, let's first look at Kw, this value over here. As we can see, it is a very, very small number. Okay, if it's a very small number, this means that it favors reactants, right? Okay, the reason why it favors reactants is because it's such a small number. So if we were to do our equilibrium constant, right, obviously if we have products on the top and reactants on the bottom, okay, it has to be a very, very, very large number here as a reactant in order for this whole value number to be so small, right, to the power of negative 14, right? Of course, if this number was really big and this one was really small, then obviously this number would be huge, okay, but it's not. Okay, this is very, very small, which means lots of reactants and a very small amount of products, okay? What does this mean? This means that only a small amount of products will actually ionize into this and this. Okay, so it's mostly going to stay as water, okay? It's kind of the whole reason why in the previous video we started off with looking at H2O liquid. Okay, and another H2O liquid over here, and then having this reversible reaction with our hydronium, okay, and our OH minus. Okay, obviously these are, oops, sorry. And obviously these here were going to be aqueous. Okay, but it's trying to say here when it says favors the reactants, because it's such a small number, it's gonna stay put. Okay, this happens all the time, like in your water bottle right now. Okay, that is beside you right now. Okay, they're always gonna be staying put as water because it favors the reactant. It's never really gonna shift towards the right. It's a very, very minimal, tiny amount. Okay, it favors reactants, so it's mostly gonna stay towards water. Okay, a very small amount of products would actually ionize. Now let's break this down further for this power of hydrogen. Okay, we're just going to break this down a little bit more over here. We're first going to look at 1 times 10 to the negative 14. This here is our Kw, and it is equal to our OH minus and our hydronium. Okay, for if you just want to put H plus, that's fine too. This is technically the same as this. Okay, so it's up to you if you want to just do it this way because it's a lot shorter and faster and easier. It's up to you. So we're going to get the log of both sides. Okay, so what is this log? Okay, the log is technically the number exponent that you need to put on top of 10 in order to get the number that you want. Okay, in case you're confused, don't worry, we're going to be looking at a few practice problems when we deal with this log. Okay, for now, let's just implement this log into our breakdown over here to see how this derives. Okay, well, we're just going to be putting a log on both sides, so I'll put a log over here. So the log has to multiply by 1 times 10 to the negative 14, because right now we're just trying to investigate this pH, okay, and this pH and this pOH, where do they come from? Okay, we're trying to break it down over here. So let's first deal with that. So our log times 1 times 10 to the negative 14, if you do it on this side, you got to do it on this side as well. So we'll put a log here, okay? But remember, this log has to multiply both of these together, okay? Because they are already multiplied together as a product. So if you put a log on this side, it's going to multiply everyone within that, okay? So we're going to be putting our OH over here, our H plus over here, and we are good. Now, this isn't finished. We're going to expand this a little bit more based on the log rule. You should know this in mathematics. When you log a product, so this here is obviously a product, okay? They are multiplying together. When you log a product, you're actually adding the two numbers together. So we're just going to bring this down as is. We're not going to touch that. But this one over here, instead of keeping it this way, I'm going to expand it a little bit. Okay, so this here will be the log of the OH minus, and we got to add this and this together. So now we have the log of the H plus. Okay, so we've expanded it out this way. Now, we're not exactly done just yet. What do you think we have to do next? Well, to avoid negative values, because if you keep it like this, you're actually just going to get a negative value. Okay, if you do a log of this, what do you end up getting when you put it on your calculator? Just try it out right now. You end up getting negative 14. Okay, if you started over here, you end up getting negative 14. We're just going to get a lot of negatives, okay, if we continue to do it this way. So to make things simple, right, because we obviously don't want to be dealing with negatives every single time when we're dealing with, you know, our calculations and practice problems. It just gets kind of annoying. Rather than making our life a little bit more difficult, we got to make it a lot easier, okay? So rather than putting a negative value for this and onwards, in order to simplify it so that everything becomes positive, you can actually just multiply this by negative 1. Okay, if you do it on this side, you got to do the same thing on that side, okay? So what you end up getting is a positive value, okay? So to avoid these negative numbers being overloaded, just multiply both sides by negative 1, okay? So you just get our 1 times 10 to the power of negative 14, okay, which would be negative 14, but you multiply by that by negative 1, you end up getting 14, okay? Again, you multiply this by negative 1, okay? You end up not getting negative 14, but you end up getting now 14, okay? It's the same thing over here, okay? What you're gonna end up doing is just inputting this negative 1 over here, okay? This negative 1 is gonna multiply whatever you have over here. So what you end up getting is 14 is equal to not just log, you end up getting a negative log, okay? You end up getting a negative log of your OH minus, okay? And then you end up getting a negative log as well for your H plus, okay? Because this negative gives you a negative log OH, and then this negative gives you another negative log H plus. So what can we mention here, okay? This negative log of our OH minus is now known as the pOH, our power of hydroxide. Similar thing here, our negative log of our H plus is known as the pH. So if we were to bring this up here and deduce a little statement, 14 is actually equal to our pOH, okay, plus our pH. Okay, this is a very important formula that you have to remember. So not only do you have to remember this, you also need to remember that Kw, okay, is equal to this, okay? This one here, our ion product constant, the equilibrium constant of water, is equal to this product, okay? And this here, this product is equal to 1 times 10 to the negative 14 as well, okay? So you have to remember this as well, along with this one over here. And it's also important for you to know that this pOH, based on what we see over here, okay, this one over here, it's a negative, right? So what is pOH individually, okay? Not just including together with the pH and the 14, but what is it just by itself? Well, it's written literally over there, okay? Our pOH is equal to our negative log, okay, of whatever concentration of OH minus is. Similarly, with our pH, what is it? Again, this here is negative, okay, so it will be the negative log, okay, negative log of our H plus concentration. Okay, so we got to look at this formula and this formula and this formula as well. Okay, at the end of this video, we're also going to look at a fourth formula as well when we look at the antilog. Now I would like you to try this question on your own. In case you need the formulas on hand to solve this question, I would encourage you to back up in this video just a little bit. Okay, so go back, maybe 10, 20-ish seconds, okay, and get those formulas down on paper. Have it on hand in order to solve this out. Okay, so try this on your own. I'll pause the video and I'll be showing you how to do this. Okay, so we have our 0.20 grams, okay, and this is over how many liters? Well, it's in 0.8 liters. So we don't like to deal with grams over liters. We're obviously used to molarity, moles over liters. Okay, that's obviously what we like to prefer. So how are we going to get rid of this grams and get it into moles? Well, whenever you're in doubt, multiply by a fraction. Okay, so we're multiplying by a fraction over here. So what goes on the bottom? What goes on the top? Well, we obviously want to get rid of this grams. We don't want it, so it has to be on the bottom here. That way, diagonally, that they can cancel out, okay, using factorial analysis. Then what has to be on the top? Well, it's the one that we want to leave at the very, very end, which is obviously going to be moles, okay? So, obviously, this looks very similar to our molar mass, okay, on the periodic table. So, for our grams, okay, what value would it be for 1 mole of NaOH? Well, just use your periodic table. You should get that it is 40, okay? In 1 mole, there is 40 grams of it, okay? Which means this grams cancels out. So what do you end up getting? You end up getting 6.25 times 10 to the negative 3 moles per liter. So this here is our concentration. Now, as we can see, this has to deal with NaOH, which is a pOH, okay? Not a pH. So what do we need to do? Well, we obviously know that we eventually want to find pH, right? It's asking for the pH, so we just got to use this formula. We can't use this yet because we don't have the concentration of H+. Right now we have here for the pOH. Okay, so I got to find my pOH first. Now pOH has a very similar formula. Okay, so what would be our concentration? It's this. Okay, what do you end up getting? You end up getting 2.20. Now, then, rather than actually using this formula, we could actually use something simpler, where 14 is equal to our pH plus our pOH. Reason why is because we already have our pOH over here. So as long as we isolate for pH, and we just use our two variables, right, 14 and whatever value this was, okay, our 2.20, we have the answer. Okay, we don't even really need to use this one right now. So right now, again, it's not alone, okay? This is bothering the pH. So how do we make sure that this pH is alone? We just got a negative pOH over here. That way these two cancels out. If you do this on the right side, you got to do it on the left side, okay? So you end up getting, right, negative pOH as well, okay? So you end up just getting pH is equal to your negative pOH, or negative 2.20 plus 14, okay? What do you end up getting? You end up getting a value of 11.80. That is the answer. Now let's say it kind of flips over to the concentration as the one that's trying to be found, but we have the actual pH value. What can we do, okay? So if we want to do it this way, let's just write out what we have. We have that our pH here is going to be 3.2, but we just want to find our concentration of our H+. Well, just get our formula. pH is equal to this negative log of our H+. Again, what is the log? Okay, maybe I'll write this here. What was the log that I mentioned ago? Okay, the log, it's the exponent. It's the exponent needed on the 10, right? Needed on the number 10 to get the number that you want. So we're going to start dealing with this anti-log right now, okay? What does this mean? Whenever you're in this kind of situation over here, right, we have our pH, which is obviously going to be a 3.2. Our negative log just kind of stays over here, and this is what we're just trying to find. Okay, we actually have no idea what this value is going to be. This is actually what we're trying to find out over here. So in this situation, you're going to have to use an anti-log. What does this mean? Well, it means when you get a H+ concentration, that you're trying to find, so this one over here, as long as you get the 10 as the base down here and you put the pH on top and you get the antilog of that, okay, which would be the negative value of that. Okay, you're going to get a negative pH, not the positive pH, okay? We're going to get a negative pH, whatever that would be. So this here will be the negative 3.2. And then you end up getting your value of 6.3 times 10 to the negative 4. This here will be your answer. Again, this will obviously be in moles per liter because we're obviously dealing with these two brackets over here, which means concentration. So you would be getting this value, okay? So whenever you are dealing in a situation where you have the pH and you're trying to find out what the concentration is, okay, and you have this negative log in the formula, you just get the antilog of that, where you put the 10 as the base, and you're trying to find the exponent needed on the 10 in order to get the number that you want. And again, you have the number, okay, you have the exponent needed, which would be 3.2, which would be just putting it on top of there. Then you have your answer, okay, as we see here. Let's try this question over here. The pOH is 2.77. If the solution is at 25 degrees Celsius, what is the pH of the solution? Well, we know what our formula is. So what do we do from here? Well, we know what our pH is going to be isolated for, is going to look like. So do the same thing over here. This cancels out, this cancels out. You got to put this on the left side as well. So you just get 14 minus your pOH. Your 14 minus whatever your pOH is going to be is written in there. Your pH ends up becoming 7.23. That is the answer. What are the pH and pOH at 25 degrees of 0.097 moles per liter of nitric acid, HNO3? This here is a strong acid. Well, let's put our formulas that we know what we need to use. Okay, we know that we need to use this one. Okay, what other formulas do we have to know that we can possibly use? Well, we know pH is equal to negative log H plus. And we know pOH is equal to negative log of the hydroxide. So out of these different formulas, what do we need to be using? Well, we obviously know our concentration of our nitric acid is 0.097. So I'll just put here on the side 0.097. Okay, this is all in moles per liter. This here would obviously be for our pH, okay? So our pH value over here, I'm just going to bring it down. I'm going to put in our values 0.097. So you're just going to be punching it into your calculator. What do you end up getting? Negative log of 0.097 in the bracket. You end up getting 1.01. Now this would make sense, okay, because if it's a very strong acid, it should be very low on the pH scale, okay? So obviously a 1 is very low on the pH scale, so this makes sense. And we also have to find the pOH. We're just going to be using our value over here, okay? Actually, no, we should actually use this one over here because we have our 14, we have our pH, so we have this and this, so we could easily just find this one. So let's use this one. So let's bring this down. So we're just going to isolate for our pOH, okay? It's going to obviously be 14 minus our pH value, so our pOH ends up becoming 14 minus 1.01. You end up getting what value? 12.99. That is your answer. These are the two green questions of the day. This is the first one, this is the second one. Please pause the video, give this a try on your own, and I'll be giving you the answer shortly. This is the answer to the first question. This is the answer to the second question.